Okay, so today we are going to look at estimating with two-digit divisors. And it says, how can you use compatible numbers to estimate quotients? So we've already talked a little bit about estimating with division. We talked about how it's a little bit more difficult. We can't just turn everything into zeros except for that first number and then like multiply or add or subtract because we have to use numbers that are going to go together. And we call those numbers compatible numbers when we're talking about division. So our first problem here talks about the observation deck of the Willis Tower in Chicago. It says that it's 1,353 feet above the ground. Elevators lift visitors to that level in 60 seconds, which is crazy to think that they go up quite that quickly. About how many feet do the elevators travel per second? So here we see the word about, and whenever we see about, we should really be thinking like they're not looking for the specific exact answer. They just kind of want a general ballpark idea, which means that we're going to be estimating. We also look at this and we know how high up the elevators go. We know how quickly they get there. And our question is not like how quickly does it do the whole thing, but how many feet, right? So how much of this upward travel does it make in every single second? So we need to divide 1,353 by 60, right? So that's how we know that this is a division problem. And about lets us know that it's an estimating division problem. So when we look at this, we want to find a compatible number that will work with our divisor of 60. So we have 1,353 divided by 60, right? Now 60 is really nice because 60 already ends in a 0. So all we really need to focus on is this 6. Now when I look at this number, I'm going to start by looking out here at the thousands place. And I'm going to think, well, 1 is really far away from 6, right? So if I turn 1,353 into 6,000, right? Like that would be crazy. So that's way too big. That's not going to work. So since that first digit's way too far away, I'm going to look at these first two here together. Now that means that I'm going to kind of consider these two digits out here to be zeros, right? I don't need to figure out how many like individual feet per second or how many 10 feet per second. This is all about estimating. So I'm going to look at this number 13. Well, I'm going to think about the number 6 and I'm going to be like, well, a multiple of 6, it's really close to 13, is 12, right? So I could pretty easily solve 1,200 divided by 60 because I can really, really easily solve 12 divided by 6. Now 12 divided by 6 is 2, right? That's very simple. But we have to figure out, right? We know that 60 times 2 isn't going to quite be big enough, right? In fact, if we did that, right, if we said 60 times 2, because remember our divisor over here is in fact 60. So 60 times 2 is, well, 2 times 6, remember, is 12. And then this is kind of that like multiplying by tens thing that we did where we took this 0 and we just added on to the end. Well, 120 and 1,200 are not the same, right? So I need to have another 0 out here. Well, I can't change 60. I can't make 60 bigger. Again, my divisor has to stay the same, right? It's not how many feet does it travel in like 100 seconds. It's how many feet does it travel every single second. So 60 can't change. But my quotient can change, right? So if I need to have another 0 here, right, what I need to do is I need to add a 0 to the back of this 2, right? Now, again, I do my basic facts. 6 times 2 is 12. I don't just have one 0, I have a second zero. So I'm going to add those 2 zeros back here. So my estimate, right, for 1,200 is divided by 60 is going to be 20, right? Now, if you paid attention, it didn't just want one estimate, it wanted 2 estimates. So we already did 1,200 divided by 60 was 20, right? So now we need to think about this again, and we need to say, well, if we have 1,352, we're going to keep 60 at 60. And again, we're going to look here, we're going to say, well, we already went down, right? Like 12 is less than 13. So what's the next multiple of 6 that's bigger than 13? Well, 6 times 3 is 18. Again, we're going to turn these other two numbers into zeros, and so we get 1,800 divided by 60. Now, again, I look here and I say, well, 18 divided by 6 is 3, right? And how many zeros go on the back of this? Well, we already did this one over here, so it's pretty easy. We know that it is 30. But another way that we can do it is, and should make sure this is nice and skinny, is we can say, well, there's a 0 here on the back of 60. So I can take that 0 and use it to counteract that 0, which means that I need one more 0 right there, which is why I would add the 0 to the back of the 3, right? So hopefully that kind of makes sense, right? Because this 0 is dealt with by that, right? Because if we said that 60 times 3 is 180, right? Like we get to that part of the number. So we need to add an extra 0 to get our answer. So that is compatible numbers. Let's try a few and see how it goes. All right, so here we are. Oh, well, let's just look at this one, right? So they've kind of done one for us, right? And you can see that they were dividing by 22 and they turned it into 20. And the reason that we turned it into 20 is because, again, it's estimating, right? And we don't need it to be specific. So we are going to add a 0 to the back, or not add a 0, I'm sorry. We're going to turn that 2 into a 0 so that 22 becomes 20, because that's going to be significantly easier. Now, they chose 14 because 14 is really close to 15, right? Like it's really, really close, and it's a multiple of 2. So here we have 140 divided by 20, and we have to find our answer. Well, 2 goes into 14 7 times. Now the question is it 7 or is it 70? Well, we can figure this out a couple ways. One way we could do it is we could say, well, 20 times 7 is 140, right? So we don't need to add a 0. The other way that we can do it is, again, we can say, well, there is a 0 right here, and there's a 0 right there. And so we don't need any extra zeros, right? Kind of thinking back to this problem where that we said that this 0 on the back of 60 got us this 0 on the back of the 18, right, 180, but we needed an extra 0. But here we don't. All right, the bigger end of our estimate, they chose 16 or 160 as a compatible number, right? 160 is really close to 154. Again, we're dividing by 20, so we think, well, 16 divided by 2 is 8. And again, because there's a 0 on the back of our 20, we don't need to add a 0 to our quotient to make up for that 0 at the end of 160. All right, let's keep moving forward and see if we can try a couple more. All right, so here, go ahead and pause it, come back and take a look at the answer and see how yours compared. All right, the first thing I'm going to do is I don't like 71. Instead, I'm going to use the number 70 because it's easier to think of it that way. So I have 5,821 divided by 70. Now, I'm going to look at these first two digits together and I'm going to think, what's a number really close to 58 that is a multiple of 7? Well, I know that 56 is a multiple of 7. I turn the 2 into a 0. I turn the 1 into a 0. So I get 5,600 divided by 70. Well, 56 divided by 7 is 8, right? I already have a 0 here, right? So I have an extra 0 in my answer. So my answer is 80, right? My answer is 80. We're going to keep 70 for our second estimate. And this time, right, instead of going down, right, for my compatible number, I want to go up, right? Because if I'm going to find two estimates, right, I want to have a high estimate and a low estimate, right? And because I used a compatible number that was less in value, then this number 80 is my low estimate. So I'm going to think, well, what's the next multiple up from 58 that's a multiple of 7? And 63 is a multiple of 7 and is bigger than 58. Again, I turn these into zeros. And I say, well, 7 times 9 equals 63. And of course, I need an extra 0 back here on the end. Now, if we're not sure if it's 9 or 90 or 900 or what it is, right, we can always break this down. Goodness, this thing drives me crazy sometimes. 70 times 90, right? And when we do problems like this, we say, well, our basic fact is 7 times 9, which is 63. And then we have 1, 2 zeros that we need to put on the back end of this. And so that works out. So our high estimate is 90. Our low estimate is 80. Okay, I'm going to do one more. It's going to be a story problem. And here it says that Eli needs to save $235. To earn money, he plans to mow lawns and charge $21 for each. Right, two estimates he could use to determine the number of lawns he needs to mow and decide which estimate you think is the better one. Right, so that's really what we're focusing on here, is which one is the better one. So for 21, it's my divisor, I'm going to use the number 20. So I have 235 divided by 20. Well, 235 is not the same as 20, right? Now, I could just focus on the 2, right? Nothing wrong with that at all. I could say that 235 is about the same as 200 and divide that by 20. And that's totally fine. That will absolutely work, right? See, so I would focus here, and I would say, well, 2 divided by 2 is 1, right? There's a 0 to deal with that one, and so the answer would be 10. So we could say that Eli needs to mow about 10 lawns. Now, let's see, so that would be our low estimate, right? Because 200 is less than 235, so let's find a high estimate. So 20 is still going to be the number we're going to use for our divisor. Now, and I can't just look at this, right? Because I'm not going to jump up to 400. That's going to be significantly more than 200. And that's the next multiple of 2, right? So instead, I'm going to get a little bit more specific. And I'm going to look at these two digits together. And I'm going to think, well, I already did a low estimate of 200, right? So let's do a high estimate. Well, the next number up, oh, and that's 5. 0 is supposed to be a 5, right? Doesn't really matter because we're not going to use it. Right, so the next number up from 23, that's a multiple of 2, is 24, right? And so then I focus on my my basic fact, right? And 24 divided by 2 is 12. Now this 0 and this 0 deal with one another, right? They're going to, for the most part, cancel each other out. So it's not 120, it's just 12. So now the question is, what is a better estimate? Is 10 a better estimate, or is 12 a better estimate? And when I look at this, I think that 12 is a better estimate. And the reason why I think 12 is a better estimate is a couple of reasons. first of all, we already kind of moved our number 21 down when we chose 20, right? So if we move both this number down and this number down when we're dividing, right, then we're really going to change the outcome, right? But if we move kind of like one down and one up, right, and we stay closer to our original, then we're probably going to be better off. And that's really what it comes down to, right? If we think about how far is 200 from 235, well, the difference between those two is that we subtracted $35 from our total. Now, when we look at the difference here between 240 and 235 here, we added $5, right? So this estimate is closer to our original problem. So 12 is going to be the better estimate for how many lawns he needs to mow in order to save $235. All right, so that is using compatible numbers to estimate division. It's really a valuable skill. We're really going to use this, especially when we do our next lesson, which is actually dividing by two-digit numbers. So give this one a try, and as always, good luck.